Welcome to this new Rise of Faces video. Today, we're going to be going over how to program a servo with an Arduino. Let's begin. First, let's go over what we're going to cover in this video. First, we're going to talk about how to set up the Arduino hardware, as in how the servo is going to be wired, how you're going to connect the servo to the Arduino, then how you're going to connect the Arduino to your computer, basic stuff. And then we're going to talk about how to set up your Arduino software, as in how to set up the Arduino IDE or the programming environment, and how to implement the servo code. And we're going to talk about how to actually upload the code to the Arduino and how to use the serial monitor. And then we'll talk about improvements to be made to our Arduino, such as a motor shield or a breadboard. Let's talk about how we set up our Arduino on the hardware side. So as you can see, I have an Arduino here. It's Arduino Uno, very simple. Got some ports on the top, some ports on the bottom. Our main chip here, flip it over, you can see all the solder joins, some very nice lettering, certifying that this is in fact a genuine Arduino Uno. Got a USB jack and a USB port and a power jack if we want to supply DC power. And then we have a little servo here, a little blue servo. Now this is a Tower Pro micro servo. This is the 9-gram model, it only weighs 9 grams. And it's a little hobby servo. It doesn't really have a lot of torque, but it's very easy to get set up and going. Really, the code you use for this can be used for any other servo. This is just to show you how it works. And then we have on the end here a little 3-pin connector, one yellow, one red, one brown. And then to actually be able to plug our servo into the board, we have here 3 male-to-male jumper cables. So what we're going to do is we're going to take our servo connector and start by plugging the brown wire into the yellow wire on our connector. The brown wire is just going to carry the signal. Now, after that's plugged in, I'm going to take the red wire and plug the red wire into the middle wire, or the red wire, which is our 5 volt power wire. I'm going to take the black wire and plug it into to the brown or ground port on the servo. Looks good, all the connections are nice and tight. So let's go and actually plug it into our board. So I'm just gonna take first the brown jumper cable and plug it into port 6, or the port that we have defined in our code. Nice and simple, nice snug connection. I'm going to take my red wire and plug it into the 5 volt port. There's only one of these, so you can't miss it. And then I'm going to plug the black jumper cable directly next to it into a ground port. With that, our servo is officially wired up. And just to give it a quick test, I'm going to go ahead and grab the USB cable, plug it into our board, and just give it a quick test run. So it's plugged in, all the lights light up, and as you can see, our servo is in fact moving, certifying that we have plugged it in correctly and that the code is reaching the servo. Now let's actually talk a little bit more about this code that we're using to actually control it. So one of the first things we need to actually start programming our servo is to get the Arduino IDE. So we're going to open a new browser window and type in arduino.cc. This will take us to Arduino's website. At the top, you'll see a few options, but we're going to go ahead and click the software option. After you do, you'll see 2 drop-downs. You're going to want to go to the downloads drop-down and click it. After you do, you'll be brought to this page. Scroll down to the downloads area, and you'll see quite a few download options. There are 3 for Windows, 4 for Linux, and then of course, there's 1 for Mac. There's at least 1 option for every type of operating system. So you should be good no matter what computer you're using. But in this case, we're going to grab the Windows zip file. So we're going to click it, and it'll bring us to this page where you have the option to just download the Arduino IDE or contribute a donation and download the Arduino IDE. Whichever you do is your choice, but in this case, you should be able to just click just download for now. You can always donate to Arduino later. After you click the just download, it'll bring up a dialog asking you where you want to store it where you choose, and then we'll move on to our next step. Okay, so now we're on my desktop, where as you can see, I have the zip file from Arduino's website that we just downloaded. So obviously I haven't done anything to it yet, I just have it saved to my desktop. So what we're going to do is we're going to go ahead and double click on it, and now we can see the file inside, and I'm going to go ahead and choose to extract it. To make it nice and easy to see, I'm just going to extract it to my desktop. And after I do, you can see, and if I click the extract button, you can see that it's got quite a few files inside. So depending on the speed of your drive and what type of drive you have, this can range from just a few seconds to a few minutes. Regardless, it will eventually extract, and we can start actually opening the IDE. So I'm just going to go ahead and fast forward to when it actually extracts. Our file has finished extracting, and as you can see, a new window has popped up showing the single folder that we have extracted. So what I'm going to do, just to make it easier for you guys to see, I'm just going to close both windows, bring down the unzip file from the corner, and just double click on it again. And it's easy to see the single folder inside. I'm just going to double click on it, revealing the contents that it has inside. So if this looks scary, don't worry. We're just going to go down to the Arduino application. We're going to double click on it, and it's going to bring up a little Arduino loading screen. After it finishes, it brings up the Arduino IDE, meaning that we are now ready to start programming our servo. Alright, now as you can see, I've closed the Arduino IDE and the window behind it, but now I have two new files on my desktop. One is Servo Display Simple, and the other one is Servo Display Complex. These are the files that you can get in the description. These are basically just the actual code files for our servo. So what I'm going to go ahead and do is just double click on Servo Display Simple, and it's going to ask me how I want to open it. So what I'm going to do is click More Apps, scroll down to look for another app on this PC, click it, and then navigate to where the Arduino folder is located. So in my case, it's on the desktop, so I'm going to go there, enter the Arduino folder, go inside the folder that's inside of it, and scroll down to the Arduino application, double click on it, and it will now start opening my file. However, before it actually opens it, it's asking me if I want to put it inside a sketch folder. It's not going to let me open it if I don't, so I'm going to go ahead and hit OK. And now the sketch is inside the folder, and now it's open in the Arduino IDE. So now I'm just going to go ahead and do the same thing for the other sketch. So I'm just going to close this one, and then double click on Servo Display Complex. And because I've already told the computer that I want to open these types of files with the Arduino IDE, all I have to do is click OK on allowing it to put it in a folder. And as you can see, I now have it up and running. Okay, now that we've made it so that we can open our sketch is inside the Arduino IDE, let's go ahead and talk about how to upload them. So I'm just going to double click on Servo Display Simple, the folder, and then actually open the Servo Display Simple sketch inside the Arduino IDE. Just close this unnecessary window and make the IDE full screen so that you guys can easily see what I'm doing. So, I mean, it's pretty simple. I mean, you can see our code in this big white area, and then at the top left there are quite a few buttons, but the one we want to be concerned about right now is the Tools button. So we're going to go up to Tools, click it, and then move down to the board. So we want to make sure it's selected as the Arduino Uno, because we're not using any other type of board like a Mega or Leonardo. So we're just going to make sure that that is in fact on Arduino Uno. If it isn't, just go ahead and click it from the drop-down list. Now, you can see that the port, the option below, is grayed out. So what I'm going to do, I just plugged in my Arduino, and now it's not grayed out anymore. And it looks like it's plugged into port COM3. So what I'm going to do is select that port, and I'm going to, that basically just tells the computer where you want to upload your code. So I'm going to click it. And now we are set as COM3 for our upload port. So now what I'm going to do is click this little check mark, the verify check mark. And it's basically going to compile our sketch and make sure that there are no errors. And it says done compiling, so we have 0 errors. And now I'm going to press this little arrow, that is the upload arrow. Now it's going to compile our sketch again. Now it's going to show that it's uploading. And now it's done uploading. So all our code works successfully, and there are no errors inside of it. Okay, now that we've talked about how to actually upload Servo Display Simple, let's just go ahead and do the same thing for Servo Display Complex. So it's really the same process. I'm just going to go through and open it the same way we did Simple. Just close this unnecessary window. And then go back up to Tools. Just make sure that we are selected on our correct port. I didn't unplug my Arduino or plug into a different port, so it's the same port, so it's totally fine. So now I'm going to come back, just make sure that everything is good in this one with the verify button. Everything looks good, so I'm going to go ahead and press the upload button. And everything uploaded just fine. So now we have our Servo Display Complex code up and running, no issues. Alright, now let's talk about what the code actually does. So right now I've just brought back up Servo Display Simple. So at the top of our code, it's really simple. We include the servo.h library. This is basically the library that our code needs to be able to give commands to the servo that we're controlling. So then after we've included, then we define a servo to be servo1. This is helpful if you're trying to define multiple servos, but we've only got one servo, so it's just defined as servo1. Then below it, we have an integer servo pos, short for servo position, set to 0. We'll be counting it in degrees because the servo travels 180 degrees. Then in void setup, we attach our servo1 to port 6 on the Arduino. It's important that we choose a port with a tilde next to it because it has the capabilities necessary for actually controlling the servo, and 6 is one of them. Then below, we initialize our serial port at 9600 baud. That's basically just a place to monitor Arduino. Then in the loop, we start by setting our servo position variable to 180 degrees. Then we write or tell the servo to go there to servo pos, which is 180. Then we wait for a second to allow the servo time to actually move there. Delay, or the time, is measured in milliseconds, so 1000 milliseconds is a second. And then in our monitor, we print current servo position, and then we put in the servo position, which is 180. And then below, it's just basically the same process that we just talked about right now, just repeated twice. So we now set our servo position to 90, tell our servo to go there, wait for another second, print our servo position, then we set our servo position variable to 0, tell our servo to go there, wait for a second, and then print our position. And because this is in the loop, this runs forever, basically until we turn our Arduino off or press the reset button. Now let's talk about Servo Display Complex. Let's talk about Servo Display Complex. So it has the same, basic underlying code as the previous one, Servo Display Simple. I mean, we include our servo library, we define a servo as servo1, and then we set an integer servo pos or servo position to be 0. However, the differences start in the void setup. The first thing we do is initialize our serial monitor at 9600 baud, then we print that we are initializing, and then we attach our previously defined servo, and we attach it to port 6 again. But this time we tell our servo to immediately go to our servo pos position, or 0, and we wait a second just to allow it to go there. This is just to make sure for when we start running our actual code that the servo is in the correct place. Then below it, we just print initialization complete because we have completed our setup code. Now in the loop, we add a integer add subtract x and set that to be 5. Then we have a for loop below it where we initialize an integer x to be 0. Then while x is greater than -1, we set x to be equal to x plus add subtract x. Basically, every time it runs, it just adds the value of add subtract x to x. And then we set our server position to x. Then we tell our server to go there. And then we delay for 50 milliseconds. We print our current servo position in degrees and pass in servo pos as our actual variable for that. And then this is actually a little important piece of code. We have a little if statement that says if x is equal to 180, then we basically set add subtract x to be -5. Now the reason why we do this is that so every time when we start this loop, we're at 0, and we progressively add 5 every 50 milliseconds of servo position, and then tell our server to go there. So basically we move 5 degrees every 50 milliseconds. When we finally reach our limit, or 180 degrees, servo can't go beyond that. So we set add subtract x, our changing variable, to be the inverse of what it was before. So it basically starts going the reverse. So it starts going to 175, 170, 165, all the way back to 0, where then add subtract x becomes 5 again, and we start moving in the other direction. And we just go back and forth forever until we turn off our Arduino or we press the reset button. Now, let's talk a little bit more about the serial monitor. Okay, so I brought up the serial monitor before, but I didn't really explain to you guys what it was. I showed you how we implemented it in our code, but we still haven't actually gone to it. So, in Servo Display Simple, we've made sure that this code is uploaded. And then we go over to the top right where we see a little magnifying glass, and if we hover over it says serial monitor. I'm just going to click on it, and it's going to bring up our connection to COM3, the port on the computer that the Arduino is attached to. And as you can see, every second it reports a new line that says current servo position, degrees. And as you can see, our servo's at 180 degrees, 90 degrees, now at 0. And then it basically goes from 180 degrees to 90 degrees to 0 forever. Now, moving back over to Servo Display Complex, let me just upload our code again, because we are just running our Servo Display Simple code. Alright, it's uploaded. Let's go back over to the serial monitor. Now, it's going to open a new one. And it says it's initializing. Initialization was complete. And now, very quickly, we can see that where our servo is. So it updates every 50 milliseconds, and you can easily see where your servo is, and you can see how quickly it's changing degrees. So the serial monitor is very helpful for finding bugs in your code. If maybe your servo code doesn't work exactly how you expected it to, maybe you could use the serial monitor report data to see what is going wrong and how you could fix it. So with that, that's all on the software side for programming a servo. Alright, we've talked about quite a few things in this video, but now let's talk about the improvements that we can make to our little project here. First of all, you may have noticed, and I already said earlier in the video, that there's only one 5-volt port on the Arduino Uno. Now, this isn't going to work out so great if you want to have more than one device run off a 5-volt port, like maybe a sensor or maybe another servo. So a way we can fix this is to take a wire from the 5-volt port and just run it to a breadboard. With the breadboard, depending on how big it is, if you just run the port into one rail, you can have the whole rail be a 5-volt power source. So you can plug as many things as you wanted. Another improvement that could be made would be maybe adding a shield to your Arduino. A shield is a second board that you can plug into the top of your Arduino. The shield we would get for the Arduino is a motor shield. And the reason why is because you may have noticed that the board is lights on it flicker when we run our servo. This basically means that the Arduino is starved for power because the servo is taking most of it, which is obviously not an ideal situation. So I would recommend purchasing a motor shield. This one I'm showing on screen is a good option. It's the Adafruit Motor Shield version 2.3. I personally have used it, and it is a very reliable board. There's also great documentation behind it, and it's really easy to get set up to your Arduino project. You just plug into the top, and then you plug your servo into one of the two ports on the top. Those ports are wired to 9 and 10 pins on the Arduino, so you would just have to change your number, your attached number in your code to either 9 or 10. And this shield also works well for DC motors, so it's designed to be able to hold servo and DC motors. Of course, if you don't like the fact that there's only 2 servo ports and there's just 4 other ports you're not going to use, maybe look into dedicated servo shields, which there are not as many of, and they're not exactly shields, but there are some options out there. And with that, our video has come to an end. Thank you for watching to the end. I hope you learned something valuable and you could start modifying this code and running with it. If you're not already, please subscribe to the channel and please leave a like if you did enjoy this video.